Okay, before you look at this video, you need to understand mechanism of dehydration of alcohol first. Okay, so from the mechanism, we know that OH, okay, OH will capture hydrogen from sulfuric acid and becoming protonated alcohol, and will leave. Okay, so we leave. So this one will become carbocation. Okay. So basically, this is your carbocation. Before we do anything, we need to observe whether this carbocation can undergo rearrangement or not. Is there any tertiary hydrogen next to the carbocation? Okay, so there is tertiary hydrogen here next to the carbocation. So we can rearrange. So the final one is like this. And next, we need to look at how many carbon next to the carbocation. So basically, there are 3 carbons. So secondary carbon, primary carbon. Okay, so if we remove hydrogen from secondary carbon, it will produce major product. So if we remove primary hydrogen, it will produce minor product. Okay, so major product. Okay, so here you have your carbocation. Okay, because it undergo rearrangement. Okay, so here you have secondary, and primary. So remove hydrogen, secondary, remove this hydrogen, so you will get double bond here. Remove this hydrogen, we get double bond here. Okay. This one is your major product. So remove hydrogen here, so you will get double bond there. The double bond must between carbocation must between the double bond must between carbocation and the carbon that you remove hydrogen, because actually something like this. So we remove this one, so that's why we get double bond here, but in this case it's something like this. So we remove the hydrogen, so it form double bond from carbon that remove hydrogen and carbon that has positive charge. Okay, so this is the major, this is the minor product, and water is the byproduct. So basically this is the major product, this is minor. Okay, so water is byproduct. Okay, same goes to this one. So first you need to find carbon attached to OH. Okay, so this carbon will become carbocation. So this is a secondary carbocation. So this secondary carbocation next to a tertiary hydrogen. So it can undergo rearrangement. So it will produce something like this. Okay, so right now, if I remove secondary hydrogen, which is this one, I remove this one, so it will form double bond here, okay, which is major product. So if I remove primary hydrogen, it will produce minor product again. So we look again. Okay, so carbon remove OH will become carbocation. We need to think first whether this one can undergo rearrangement or not. Okay, this one can undergo rearrangement because next to the carbocation has tertiary hydrogen. So we can rearrange. So move here. So this one will become carbocation. when you have your carbocation, you need to think which hydrogen will be removed to form major product. Okay, so basically there are 3 carbon attached to this carbocation: primary, secondary. So this is secondary hydrogen, this is primary hydrogen. Removing secondary hydrogen will produce major product. Removing primary hydrogen will produce minor product. So your major product like this. Okay, so your minor product is like this. Okay, so if we check according to zigzag rule, so if you want to use zigzag rule, you need to circle carbon-carbon double bond. Okay, so basically there are 1, 2, 3. Okay, because this one is attached to this carbon. Okay, this one is attached to this carbon. So there are 3 alkyl group. Okay, there are 3 alkyl group attached to the carbon-carbon double bond. But here you only have 2 groups. Okay, group number 1, group number 2. Okay, the other 2 is hydrogen. So that's why this is the major product. This is the minor product. And then water is the byproduct. Okay, similar like before, you need to find carbon bonded to OH. So this is the carbon. So when OH leave, so this carbon will become secondary carbocation. So we can rearrange the secondary carbocation to become tertiary carbocation. So this is the tertiary carbocation. Okay, so initially the carbocation is here, so we rearrange, we shift the hydride, so we will get tertiary carbocation. So this carbon attached to 3 carbons which are primary, and secondary. So if we remove secondary hydrogen, so we will get major product. So if we remove any of primary hydrogen, we will get minor product. So this is the minor product. Okay, you remove one of the primary hydrogen and water is byproduct. Okay, for this one, carbon attached to OH, so this carbon already tertiary. Okay, so you will have tertiary carbocation if that carbon, if OH leave as water. So you already have tertiary carbocation, so no need to rearrange. Okay, so this carbocation attached to 3 carbon, which are this one, secondary, and primary. Remove any of secondary hydrogen, you will get my major product. Whether you get like that or like this, actually these two are similar. Okay, both are major product and both are same structure. So you only need to draw one of them. Okay, and then when you this is carbon attached to OH. So this is your carbocation. So when you remove this OH and this hydrogen, okay, so this is where your double bond. So this is your minor product.